Now we're going to look at dynamic binding and kind of figure out what that means, why it's important, and some of the benefits that Java provides to allow this type of behavior. So this is all in the class files, but if you are to open the dynamic binding static binding Word doc, you'll see this UML diagram, and also the picture itself is available along with the source code in the source code file. So let's look at some of the differences we haven't seen yet. At first glance, it seems pretty basic, pretty straightforward. So you've got this pet superclass with these subclasses cat and dog. Looks like they're inheriting some methods and some functionality from pet. But notice if you look very closely, you'll see pet is actually in italics, and also this calc human age is also in italics. So when you see something that's italics, you can imagine that something is abstract. So pet is an abstract class because one or more of its methods are declared abstract, which is this one right here. And it has a lot of methods that are constructors and getters and setters and things that are not abstract. It does have at least one method that is abstract, making the entire thing abstract. So cat and dog need to provide functionality for this calc human age. And when we look down here at the bottom, we see both of those in fact do that, and they also provide constructors and some getters and setters for some other things. That's kind of a quick overview of what we're going to be looking at in the code. So let us take a look at the actual code. So bring up Atom. So this is just a text editor that I have that I use that I like, and is pretty good. But so this is the abstract class pet. You see, like we talked about, this looks pretty generic and straightforward. The only thing interesting is this public abstract, method that needs to be overridden. Any class that, uses this pet abstract class needs to provide that functionality here. So we'll take a look at the dog.java. Cat.java is the same thing, but we'll just look at this one. This is the subclass. It's extending pet, so it's extending this abstract class pet. It's providing its own getters and setters, constructors, and then here's the key thing here. So this is the overridden abstract method from the superclass. So if we remember, this is the thing that was declared abstract over here. So we've got this int calc human age, and now we've got dog using it, and then it's just returning 9 times get years, right? So it's just kind of the rough math of what the dog's age is going to be in human years. And the only thing that's missing from this is this override statement. So this will actually, during compile time, catch any errors that might occur. So while it's not required, this is definitely something that you would want to do in your programs. So now let's take a look at this test pet that uses these two things. So we know this is going to be dynamic binding. So what exactly is dynamic binding? Well, that's what we call late binding or runtime binding. Things that are statically bound happen at compile time. So at compile time, the JVM needs to determine what's happening. When it's dynamic binding, the JVM can actually determine what's happening as the program runs. So it's really cool how you can do this kind of stuff. This is the test pet program. So we're using the pet and dog classes in here. And you'll notice we declare a pet myPet reference variable up here. We've got this myPet object up here. Then we're saying, what pet do you want to have? We get their choice. And then from there, if it's a 0, it's a cat, and 1 for a dog. So let's say they selected 1. So we create a new German Shepherd brown dog that's 5 years old. And we assign this object to this pet object. Okay? And then we calc the human age with this myPet object, which is of type pet, and it's able to determine the pet's age. So why is this significant? Well, when we compile this program, the JVM has no idea what myPet will be. It could be either a cat or a dog. it's smart enough that when the program is running, it determines and it says, oh, okay, so my pet's now a cat. So based on that, I'm going to use the method calculateAge from the cat object. Or in our example, it says, oh, okay, it's going to use my pet's a pet, but it's actually assigned to be a dog. So that means I've got to use the calculateAge from my dog class, which is down here, and it determines that. There's some text also in this testpet.java. Basically, it goes through what I just talked about. So it's pretty cool. So dynamic binding is really interesting. Static is pretty much the exact opposite. It has to happen at compile time, and it's not a dynamic thing that the compiler can figure out on its own. Pretty cool stuff, and it's one of the very interesting things that Java is able to do. So